When military personnel are out in the field, the heavy protective uniforms they wear can weigh them down. But a new material may be able to counteract this problem. Scientists have invented a fabric that is highly breathable and can protect military personnel from biological and chemical threats. The material has been created by researchers from the Lawrence Livermore National Laboratory in California, and is published in Advanced Materials. The researchers say the material is the first key component of futuristic smart uniforms that will respond to and protect from environmental chemical hazards. During missions in contaminated environments, military personnel can become overheated and exhausted, so high breathability was a critical requirement. Current protective military uniforms struggle to find a balance between comfort and protection, and provide a passive rather than active response to an environmental threat. The researchers created a flexible polymeric membrane which integrated tiny carbon nanotubes as moisture-conducting pores. Dr. Ngakbe, who led the study, said, "We demonstrated that these membranes provide rates of water vapor transport that surpass those of commercial breathable fabrics like Gore-Tex, even though the CNT pores are only a few nanometers wide." The CNT pores were shown to increase breathability of the material by more than 10 times. Additionally, because the CNT pores were so small, they could also provide protection from biological agents, such as bacteria or viruses. During testing, CNT pores were able to repel the dengue virus by preventing it from entering through the material. While biological agents are usually too big to fit through, the biggest challenge was creating a material that could repel chemical agents, which are usually a lot smaller. The researchers modified the CNT pores with chemical threat responsive function groups that sense and block chemicals at the pore entrance. They are also in the process of developing a second response scheme which will cause the fabric to exfoliate, peeling off the layer, when it reacts with a chemical. Dr. Kuang-Jen Wu, leader of the LLNL Biosecurity and Bionanosciences Group, said, "The material will be like a smart second skin that responds to the environment." The next step for the researchers is to design a material that can undergo a rapid transformation from the breathable to protective state. Dr. Francesco Fornizzaro, the principal investigator said, "These responsive membranes are expected to be particularly effective in mitigating a physiological burden because a less breathable but protective state can be actuated locally and only when needed." The researchers hope that the material could be used to make new uniforms in less than 10 years.